All right, yesterday we started working with addition of vectors, Victor, and just drawing them out. Now, when you draw them out, you just need to make sure you draw in a resultant vector with respect to it. Just don't go 3 plus 4 is equal to 3 plus 4. Draw in the resultant vector, and once again, that is the big bad wuss way to shortcut, or shortcuts way to grandma's house. When I'm drawing in my two vectors, wherever they're at. If I have A plus B and I'm drawing them in here, you need to draw in the result from the initial position to the terminal position and going in this direction. Do not forget your arrow that is at the terminal position. Common mistake that you have when drawing these, you'll draw in the A, you'll draw in the B, and then you'll draw in the resultant vector, but then you'll put the arrow on this end. Well, what you're doing is you're just going around the vicious circle here. You're going from here to here and then back to here, so you ended up where you started. Need to make sure that you get the arrow at this terminal position for both of these. Okay, this here is a terminal position, both of the resultant vector, and also the two vectors that you're adding together. Okay, so it goes at the end. Questions you have about any of the drawings? You had the solutions there. Basically, it's just using your straight edge, and you want to try to maintain as close as possible the length and the direction of the vectors that you're drawing there. Typically, what I will do is I'll hold my straight edge up to a certain vector here, and then I'll slide it down and try to maintain that exact same direction as I slide down. That's what I do, just to try to keep the direction going the same. And you want to try to have close enough as possible the same length that you're dealing with there. All right. Today, what we're going to do, yesterday we did everything with respect to graphing. Today, what we're going to do is we're going to throw numbers into this. We're going to throw the numbers into this, and we're going to work through problems with respect to numbers. What we have here is we have two vectors, A and B, that are connected at their tails. We got a cat dog idea going on there. Cat dog used to be an old cartoon. I don't know if you guys ever watched Cat Dog. Cat dog, cat dog. It was sort of a weird cartoon. You had one end cat and the other end dog. It was weird. There you go. You guys can YouTube that and say cat dog. YouTube your cat dog. That was an old school cartoon. It was a little funky, but we have these two vectors connected at their tails here. We have the magnitude, and how we signify magnitude is a double absolute value. The magnitude is the length of the vector, and once again, it depends on what book that you're looking at. Sometimes they'll just do single absolute value there, but once again, I don't like that because it has a double meaning to it. When you have a double absolute value there, that signifies you're dealing with a magnitude, and then that's a little bit clearer in my book, but some books will just single absolute value that and put a symbol of a vector above it. I don't like it, but once again, you'll run into that. The magnitude of A is the value of 8. The magnitude of B is the value of 10. We want to calculate A plus B in the vector world. Well, A plus B, if you would just literally look at numbers, A plus B, 8 plus 10, you come down to 18. But in the world of a vector, 8 plus 10 is not equal to 18. Because what we have is we have different lengths in different directions here. If I had 8 units here, and then I have 10 units here, yes, that's a total of 18. But that's all in the linear world. And I'm not in a linear world. I have different angles in that. I'm in the two-dimensional world. So what we want to do is we want to be able to add A plus B. The angle that's connecting these two is a 40-degree angle. So the first thing that we want to do is we want to draw A plus B. So if we take a look, here's my length A and my direction A. This is my A. And to add B to that, I'm going to travel, this is my initial position here. I'm going to travel length A, which is a total of 8 units. When I stop A, the terminal of A, the terminal point of A, I'm going to start B. Maybe. There we go. So I have B, which is a total of 10 units. And what we want to calculate is we want to calculate the result of A plus B. So I'm going to draw in my resultant vector. There's my VR. Now, the length of VR, looking at the idea of a triangle, length of VR. If I compare that length to that number, the magnitude of VR to 18, can VR equal 18, or is it going to be greater? Could it be greater than 18, or is it going to be less than 18? If I compare it to 18, would it be equal to 18, VR equal to 18, less than 18, or greater than 18? Less than, smaller than 18. Because you can see if these were flattened out, and I would sort of push this down, then I can make an entire length here that's linear. That could be 18. But this goes into the property of triangles, which we talked about when we talked about law of sines and cosines. If I add up any two sides of a triangle, the sum of any two sides of a triangle has to be smaller than, or has to be greater than the third side. Okay? If I add up these two right here, it has to be bigger than this, the third side. And that's what we have here. This has to be smaller than the sum of these two sides. So what we have created is we have created a triangle. I know two sides of a triangle. I need to find the third side. Hence, going back into what we just did, the Pythagorean idea, if we wanted to, if we had a right angle there, or the law of sines and cosines, which we just finished up. Well, to use the law of sines and cosines, we have to calculate, or we have to know an angle. Well, the angle that's given to us is 40 degrees. We need to incorporate that 40 degrees within this triangle somewhere. Well, if we take a look what occurs here, all I basically did was took B and we slid it up to the tip of A. Well, when I start taking B and sliding up to A, I maintain this angle, so that is 40 degrees still. If I slide it a little bit further, I still have 40 degrees there. If I take it to the tip here and extend this side, I still have 40 degrees. So if I would extend this side, this would be 40 degrees, which within the triangle then, the angle within the triangle has to be what measure? 140. This has to be 140 degrees because what we have here, what we have here is in geometry, when you're down in geometry room, we called this a linear pair. And then you proved if two angles were a linear pair, then those two angles were supplementary. Two angles are a linear pair, then they're going to be supplementary. So if this is 40 degrees, this has to be 140 degrees, which now gives me two sides of a triangle, the angle included. I'm going to solve for the third side, which allows us to set up a law of cosines equation. A law of cosines equation. So set yourself up a law of cosines equation allows you to solve for VR. Now, mind you, and remember, when you set up your law of cosine, that gives us VR squared. So you'll have to take the square root of that to be able to find VR. Either one you come up with. 16.93, good with that, which is smaller than our 18. We also need to have a direction. So the direction I'm going to ask you, or will be asked in the homework, is what is the angle that is formed between the resultant vector and vector A? Vector. So I'm going to call this an alpha value. I'm going to call this alpha. Alpha looks like a little fishy, okay, but we don't connect the end of it. It's a little fish. There we go. That's your alpha. Well, what we can do, since this angle is already 140 degrees, we already have an obtuse angle, I can use my law of sines. So I can set up my law of sines. I have angle, length of side opposite. Length of side opposite, I need to solve for alpha. So go ahead and set up a law of sines equation and solve for alpha. Because we're dealing with vectors here, we need to have a magnitude and we need to have a direction. So we need to get some sort of angle in there. Vanessa, what do you get for alpha? 22.31 degrees. Good with that? And if you're up by a penny here or there, don't worry about a penny. Okay, don't worry about the penny. Well, if we have A minus B, we're going to travel A and then we have to go the opposite to B. Well, if I add B, I go in this direction. That's if I add B. If I go the opposite to B, that means I'm just going in the opposite direction, which means I'm going in this direction. So this is your negative B. And we draw in our resultant vector. Victor. Magnitude of A is still 8. The magnitude of B is still 10. We don't give this a length of negative 10 because I have a negative B there. The magnitude or the length of it is still a length of 10. This is what we originally had, and we had that angle is 40 degrees. What's our angle between A and B now? This 40 degrees was also this 40 degrees here. What's my angle inside the triangle then? 40 also. We can look at two different things here. We can look at these two angles are called vertical angles. They are vertical angles. Or we could take a look at this line and this line are parallel. We have a transversal. These are alternate interior angles. You can look at it either way. And once again, now you have the exact same law of cosines equation up here, but now this gets changed just 40 to 40 degrees. So we have BR squared is equal to 8 squared plus 10 squared minus 2, 8, 10 cosine of now 40 degrees. Okay, so it just changes a little bit in regards to your law of cosines. You're still using the exact same magnitudes. We just have the angle that's a little bit different. If we need to, we can find this alpha, but we'll just get a value down here. Rachel, what do you get for VR? 6.43. We good with that? All right. Once again, what is used, where vectors are used a lot, Victor, is in the aeronautical world or in the nautical world. That means you're traveling in a boat. Because when you're in a boat out on the ocean, there's no roads out there. I'm not just going down the road here on the ocean to get over to England. When the Pilgrims sailed the ocean blue in 1492, they just went that way. And they had no clue which way they were going or where they were going to end up. They just went that way. They had no clue. There was no roads. There was no maps that were there. They just went that way. Well, you have all types of ocean currents that occur out there that will make the boats travel in different directions. If you've ever tried going canoeing and you tipped over your canoe and you're on one river bank and all your friends are over in the other river bank and you want to swim to them or row the canoe over to them, and you take off going straight across the river to get across the river to them, you end up 20 yards down the river because the current of the river will take you there. Even if it looks nice and smooth out there and you start traveling, trying to swim across or canoe across, you're going to end up down the river. Currents are going to make you move. There's nothing holding you there. Well, that's the boats out there in the ocean also. Or if you're up in the air in a plane, there's no roads up there. There's nothing to hold you in a spot. The wind is blowing in a certain direction. It's going to push you somewhere. There was a plane, a U.S. plane, United States plane, that got blown up by the Russians once, back in the 1980s, 1990s, blown up by the Russians. Reason why is it was a passenger airplane that drifted over Russian airspace. The Russians said, oh, that was a spy plane, and they blew it up. It was all passengers on this plane. And basically, the reason why, the fault that they put why this occurred was they called pilot error. Basically, what you're talking about with respect to pilot error is the wind shifted. The wind shifted and pushed the plane over Russian airspace, and the Russians blew it up. If you have a strong north wind, 25, 30 mile an hour wind, and you're traveling from Cleveland to Chicago, and you take off going straight to Chicago in an airplane, and you have the strong north wind, what will happen is you will end up in St. Louis, because the plane will get pushed by all that wind. Shoot a basketball. Down there at the park, shooting the basketball on the outside. Wind's blowing pretty hard. You start aiming at the hoop and you're shooting the basketball. Basketball lands over there, misses the hoop entirely. Reason why? The wind is blowing it. So you have to have the idea of vectors when dealing with traveling. Victor? We have dealt with theta throughout our entire degree measurements. Theta is what we call an east reference for the initial side of an angle. When I talk about east reference, if we put directions to an axis, we have north, we have south, we have west, and we have east. This always says we. What we have dealt with up till now is an east reference with respect to initial side. So we would rotate here, and this was our measure of theta. When you talk about airplanes and boats, they deal with bearing. And with bearing, this is a north reference with the initial side of the angle. And clockwise is a positive rotation. Clockwise is a positive rotation. If you ever watch movies and they go into, they're on an airplane or they're on a boat and they're talking to the towers in regards to air traffic control towers. There's flight plans that are there. They talk about traveling on a specific bearing. And what they have, well, they don't have it anymore, but in the old school, they used to have a little compass that is sitting there. Why do we deal with a north reference. Because if we're Boy Scouts or we know anything about the idea of a compass, it is based off of the North Pole. You have the magnetic North Pole that denotes whether I'm going north, south, west, or east. Because you have the magnetic North Pole that pulls the needle there. That's why bearing is a north reference. When you're up in the air or out in the middle of the Atlantic Ocean, you have no clue. You walk out on the deck, you slept all night long, you walk out on the deck and you look around and go, okay, the sun's not up, which is north, south, west, and east? You don't know. But if you put a compass there, the needle will always point towards the north. And then you can figure out which direction you're going. That's why we use bearing. Any compass, you have a little digital compass there, you have a little compass, it will always point to the north. Plane travels on the bearing of 70 degrees for a distance of 100 kilometers and turns on a bearing of 140 degrees for 200 kilometers. What's the plane's distance direction from initial position? Here is our north. This is a bearing of 0. We are going to fly in a bearing of 70 degrees, so we are going to rotate this 70 degrees. So basically, we're traveling in this direction. We're traveling northeast. We're going 70 degrees off of north. At this point, we then turn and go on a bearing of 140 degrees for 200 kilometers. Now, what I suggest you do with this is the easiest way I have for you to get through these problems. Wherever we stop our first vector, draw another little axis there. This is your north. Draw a little axis there. This is 0 degrees. We're going to go on a bearing of 140 degrees, which means I'm going to rotate clockwise 140 degrees. So I have 90 degrees here. This is 180 degrees here. So I'm somewhere between 90 and 180 degrees. We only have positive directions with respect to bearing. We don't ever go on a bearing of negative 30 degrees. Okay, we just go on a bearing of 330 degrees. We don't go past 360 with a bearing, because if I'm up there in an airplane that says, okay, we have to go on a bearing of 720 degrees, we're not going to spin the airplane around in circles twice to go in that direction. What we want to find is the plane's distance and direction from the initial position. So we want to find our resultant vector. What is the result to adding this vector and this vector? What's the result? What is the big bad wolf's way, shortcut way to grandma's house? You know, why they do things like this. Sometimes, okay, I don't want to fly at a high altitude. I have to go around the mountain. Or maybe there's a huge storm. There's a huge low pressure system there that I don't want to travel through with my airplane. Why? Because I'll end up acting like a basketball, bouncing up and down. And if you've ever been on an airplane and you're bouncing up and down, that's not much fun. Well, what we've just done is we've just set up a triangle. With this triangle, we can use our law of cosines. Well, to use our law of cosines, I need to know two sides and the included angle. Don't know the included angle. That's the game with this. That's the game with this. I need to calculate this included angle here. Now, how you do that is most of the time you're going to do it in pieces parts. Okay? You're not going to do and solve for the entire angle all at once. The easiest pieces part would be this one right here. If I rotate from here to here, that's 140 degrees. What's this little small piece have to be, Jacob? 40 degrees. That has to be 40 degrees because I have to have a total of 180. This one you have to look a little bit harder for, but the nice thing about this is when you draw these axes, you have vertical and horizontal lines. Vertical lines or horizontal lines are all parallel. Vertical here is parallel to vertical here. Horizontal here is parallel to horizontal there. Vectors act like transversals. So you can look at the idea of alternate interior angles or exterior angles to be able to find measures of angles. What does this measure of this angle have to be? 70. Because if I look at this line and this line being parallel, here's my transversal. These are alternate interior angles. So if this is 70 here, this has to be 70 there. So my total amount for this angle is 110 degrees. So now I can set up a law of cosines equation. I know this measure, I know this measure, I know the angle that's included. So I can set up a BR squared is equal to, set yourself up a law of cosines equation and solve for VR. Check your answers with somebody around you. Manny, what did it come down to? 200.34. Yes, no, maybe so. Paul?
I got 252.35.
252.35. Yes, no, maybe so. Is that better? All right. We have 100 squared plus 200 squared minus 2 times 100 times 200, cosine of 110 degrees. Once again, you can type that straight into your calculator as is. You don't have to do pieces parts. Just type in 100 squared plus 200 squared minus 2 times 100 times 200 times the cosine of 110 and hit enter. That gives you VR squared, and then you can square root your answer. Now, we need to have direction also because we need both elements here. My direction, you always go to the vertex, always go to your vertex of the angle at the original origin, which is this angle right here. I'm going to call it alpha. I'm not going to go theta and beta in there because that gives us different meanings. Okay, so here's my alpha value. I already have 110 degrees here, so I don't have to worry about the supplement to that. So I can set up my law of sine, sine of alpha over 200, sine of 110 over 252.35. This is kilometers. Skylar, what do you get for alpha? I'm sorry, what? 48 point what? 48.14. Go with that. All right, good. All right. But we need to change this back to a bearing. We found this alpha to be 48.14. Bearing is, what is my rotation from here to here? What is my bearing from here to here? Because I'm going from my initial. So what do we have to do to find my actual bearing here? What can we find to find this? Add 70 to it. So to find my bearing, I can add 70 to this to give me a bearing of 118.14 degrees. Once again, it's always nicer when you have angle measures or you have numbers that get thrown into the problems. And what you can see with these problems is you basically go back to your law of sines and cosines. You have to now come up with a triangle. Okay, and that's the difference to what we just did last week. We dealt with law of sines and cosines. I just gave you the triangle, and you had to find sides of the triangle. Now, what you have to do is you have to come up with the triangle and apply your law of sines and cosines with that. Solutions have been posted for you with respect to these. Give you something to do today if you're not doing anything in other classes.